We'll proceed in summation and integral calculus. Okay, summation and integral calculus, how we can solve our problem. If I have a problem, then how I can solve my problem, how I can solve a problem, how we can solve a problem by dividing the problem into n different parts. Solve the problem part by part. Solve the problem part by part and then sum it. Summation. First divide the problem into different parts and then solve the each part and then sum it. Okay, if someone is dividing the problem into 10 parts, 20 parts, then it is workable. He can later sum it. What about if someone is dividing the problem into 100 parts, 200 parts, and then he is trying to solve the problem? Okay, he is dividing the problem into n number of parts. If n is 2, 3, 10, then it is solvable. If n is 100, 100, 1000 and something like that, then it is pretty difficult to solve it. Okay, why someone need to divide the problem into 100 parts? Why someone, if I am solving a problem, it is understandable that I'll break it into 3 part 4 part and then solve it. Like I have to measure. Okay, there is no rope here. Consider there is a rope, there is a big rope, and I have to measure the length of the rope. Now to measuring the length of the rope, understandable, right? If I have a big rope, I don't know where. Consider there is a big rope. Rope is very big and I have to measure the length of the rope. What I would do is I'll fold the rope into 10. Means if this, okay, consider this is the rope, very big rope. Then I'll fold this like this, rope like this, rope like this. Now consider the 10 fold I made the rope, 10 fold. And then I measure the length of 1. Then I know all are of equal part, multiply by 10 or add it 10 times. That is the length of the rope. Rather than measuring all the length of the rope. That is very difficult. So that is dividing a problem into n number of parts and then solving the problem, then solving the problem part by part and then adding it. Okay, why we need more than that? Not required. If my capability is to measure a length of rope that is 5 feet, 5 feet in the length, and my rope is 50 feet, rope is 50 feet, I'll fold it 10 times, or I'll measure 5 feet and then I'll take this side. Then next 5 feet, I'll take this side. Next 4 feet, then I take this side. Next 3 feet, I take this side. Next 5 feet. Like this, I'll keep at dividing into different parts. And this is what anyone would do. If someone is sitting and measuring the length of a rope, he would do in this fashion. Then how much time, how many times I need to measure the length of the rope? 10 times, 20 times, it is feasible. Consider that I divide the rope into n part where n tends to infinity. First of all, why you need infinity? That is the question anyone would ask. Okay, I understand that you divide your problem into different parts and then measure the one part by one part and then at the end sum it. Summation I equal to 1 to n length of ith section. That will give the length of the full fledged rope. Understandable. What is the length of rope? Summation of I equal to 1 to n Li. What is Li? Li is the length of the ith section of the rope. Understandable. Where n tends to infinity. Why you need infinity? That is the question mark. Why you need infinity? We need infinity when we are approximating things. Then we need infinity. Where you are approximating things, like circumference of a circle, these kind of. If I'm trying to calculate the length of something, what is the length of this line? What is this line? This line is, this is x-axis. Equation of this line is y equal to x square. Okay, when x is 1, it is 1. When it is 2, then it is 4. When it is 3, it is 9. When it is 4, it is 16. Okay, y equal to x square or y equal to x square. This is the this is the equation of the line y equal to x square provided x is greater than 0. Okay, x is minus infinity to plus infinity. If I say like this, then this is y equal to x square. When x is 0, it will touch the minimum point, global minimum, not the local minimum. Global minimum. Otherwise, it will go like this, and this side it will go like this. Now calculate the length of this curve from x is minus 3 to plus 3. Measure it. Okay, how you measure? No one can measure. It's a curve. Okay, I know. I'll measure it. Don't worry. How you will measure it? Minus 3. If this is x is minus 3, it will go up to here, that is 9. When x is 3, then it will go up to here, 9 again. Then this is from here to here, I have to measure the length. I'm going to chop it. I'm going to chop the line, not the x-axis. There are two ways. One is I'll chop the x-axis into n part, n equal part, or I'll chop this line segment into n equal part. Consider I'm chopping the line segment where x is 3 and y is 9, and x is minus 3 and y is 9. This line segment I'm chopping into n part. I'm chopping into n part. Okay, thank you very much. Now measure the length. If it now measure the length. Now since it is divided into n part, consider this is the first part, second part, third part, ith part, nth part. Now how I measure length of this? What I would do is I'll take this point and this point. Take a straight line and measure the straight line. The curved line not possible to measure at all. So I'll between these 2 points, I'll measure the straight line distance, 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 straight line distance. Add it. Summation of I equal to 1 to n. Summation of I equal to 1 to n, length of the ith section. No. How you can say like that? It will not be accurate. Okay, it will be accurate. Divide into 2 parts and try. This is 1 to 0, one part, and another part. Take the straight line and add it. Now divide into 4 parts. Try. 4 part will be better result. Divide into 10 part. 5 part this side, 5 part that side. 10 part. Result will be even better. Oh, understood. If n tends to infinity, then it will be exact length of the curve. If n tends to infinity and we are dividing into n part and then we are summing it, from a human it is not possible to sum it. If n tends to 100, probably some dragon can do it, but n is 100, 1000, 10,000, 1 lakh, 10 lakhs, 1 crore. I mean 100 crore, 100 crore is 1 billion. Still someone will say, still part per million. Small error is there. But I divided n tends to 1 billion. Still error is there. N tends to infinity, yeah. If n tends to infinity, then there is not any error. If I sum it, summation of I equal to 1 to n, summation I equal to 1 to n, length of the ith section where n tends to infinity, this summation is not possible by any human. Then I have to apply some mathematics, and that mathematics is called integral calculus. Then there are 2 steps here. First, to find the length of the ith section in the generic manner, not by tape. Okay, in a generic manner. Generic manner in the sense in a function of some independent component. Like if I have x-axis and if I have y-axis, x is independent component, y is dependent component. Okay, what are other? If I talk about circle, then there are 2 more things come into the picture. One is called radius. One is called radius. This is radius, and one is called angle. From here, it forms angle. Up. There are 4 things you are talking here. Yes, I am talking 4 things. One is x-axis and one is y-axis. This is Cartesian coordinate. Yes, this is Cartesian coordinate. Okay, one is radius and then angle. This is polar coordinates. Yeah, this is polar coordinates. But you are showing both things in one graph only. This is Cartesian coordinate system. In Cartesian coordinate system, I am drawing the polar coordinate system. Polar coordinate system altogether it is different. If this is if this is Cartesian coordinate system, if this is Cartesian coordinate system, then if this is Cartesian coordinate system, then this is called polar coordinate system. This is polar coordinate system. I should have. There is no one more. Okay, okay. This is polar coordinate system. Then this is Cartesian coordinate system. Both are together now. I'm showing up. It is difficult. Okay. This is Cartesian. This is polar coordinate system. This is theta and this is r. This is Cartesian coordinate system. X. This is x axis. This is y. Both are different. But I can draw polar coordinate system in the Cartesian itself. Okay. In that fashion, if Cartesian coordinate system and polar coordinate system, they are related to through some function, like x is function over r and theta, x equal to r cos theta, y is function over r and theta, y equal to r sin theta. If they are related to each other, then if I draw a basic diagram in the theta r plane, if I draw, what is the basic diagram in theta r plane when they look like a straight line and perpendicular to each other, a rectangle. If I draw a rectangle here, that rectangle will get mapped into xy plane as a circle with the relationship x equal to r cos theta and y equal to r sin theta. Prove it. Prove it, it will be a circle. How I believe that x equal to r cos theta and y equal to r sin theta, and in theta r plane there is a rectangle. It will map to a circle. Prove it. Okay, I'll prove it. If x equal to r cos theta, y equal to r sin theta, then r equal to x square plus y square square. R equal to x square plus y square square root. What is x square plus y square square root? If I have a, this is x and this is y, there is one point, and this point is x square, and this point, if I say y square square, this will be hypotenuse. Everywhere I change the x, the hypotenuse will go like this, because it is x square plus y square square root. Or I would say r square equal to x square plus y square. This is typically a formula of a circle only. Oh, understood. So the r theta in xy plane, r theta rectangle in r theta plane, it maps to a circle in in xy plane. So in xy plane, I have a hybrid model now. In xy plane, I have a hybrid model now. I have drawn a circle in xy plane. If I talk like this, then this is x-axis, this is y-axis. This is radius that is moving like this, making angle theta. Though theta and r, radius and theta, they are separate coordinate system. Okay, we are talking about finding the first. If I talk about the length, if I talk about the full length of a curve, like we talked about a parabolic curve, full length of the parabolic curve, I divide into n section. Summation of I equal to n length of the ith section. Summation sigma sin I equal to 1 to n, capital L, subscript, bottom right I. Okay, that is the expression for the ith component. I have to make a generic formula. I have to deduce there, not measuring by the tape. Like generic formula means a formula, a mathematical formula, mathematical deduction that includes independent component. That is called generic thing. Like if I talk in xy coordinate, then it must compose x. Y is not required because y is function over x. If I draw a curve in xy plane, makes sense? Or it will be in function of r and theta. What are you saying r and theta? R and theta, they are another coordinate system where if I draw something, then R will be dependent upon theta. I'm not talking that. This is called miniature of mathematics. If someone is writing mathematics formula, then there is a miniature inside it. What is miniature inside it? If I take r theta plane, this is theta axis, this is r axis. If I take r theta plane and if I draw a graph here, then r is function over theta. Okay, but if this side, or if I have if I have xy plane where y is function over x, in that if I am drawing a hybrid r theta here, okay, in that fashion r and theta both are independent component and x, y are dependent upon r and theta. Makes sense? Okay, what is hybrid model? This is x-axis, this is y-axis, this is the radius that is making angle theta with the x-axis. Now, all four things we are dumping in one diagram only, whereas r theta is separate coordinate system and xy is separate coordinate system, but in xy. Okay, can you dump xy in r theta? You're dumping r theta in xy plane, right? Yes, I'm dumping r theta in xy plane, where it forms a circle and radius is moving like this. Why radius is moving like this? Because radius square equal to x square plus y square. Keep the same relationship. X equal to r cos theta, y equal to r sin theta. Now draw this circle that is in xy plane to this circle. Now, I'm sorry. Now draw anything in xy plane into the r theta plane. Can you do reverse fashion? Someone can try. There's no one stopping anyone. How it would be? Here r is a function of x and y, and we deduce a circle, right? R square equal to x square plus y. If you want xy to r theta, these are not mentioned in any of the book. Reverse fashion. Then you have to specify x in r and theta, that is r cos theta. What is x equal to r cos theta? What is x equal to r cos theta? If I talk about here, if I talk about in theta r plane, this is theta r plane. Here, this is theta and this is r. Where is x? I don't know. But x equal to r cos theta, that is for sure. If r is constant, then x equal to r cos theta. Looks like if the way theta is growing, x will go as a cos theta. Maximum will be r. R cos theta means it will have maximum. This is r cos theta. At theta equal to 0, it is r maximum. And then theta is equal to pi by 2, it is 0. Then it will rotate like this. This is x in r theta plane. These are $1 trillion explanation. No one would find this much. What is xy mapping into r theta? Xy mapping into r theta will be like that. X equal to r cos theta. If r is constant, okay, if r is constant, then it will make a cosine wave. Y equal to r sin theta. Then if r is constant, it will make a sinusoidal wave. So these x and y will be in waveform of cos theta and sin theta. If r is function over theta, then think about it. Okay, r theta to xy mapping I'll talk. Someone can do in that. Consider this as an assignment now. Someone can do there also. Anyway, when we are talking about r is a function over r and now we are talking about both are inside the xy plane. This is xy, this is xy plane, this is xy plane. Consider this is xy plane, and there is a circle, and radius is moving. Radius is moving like this because r equal to x square plus y square. If that is the case, then we have two independent components here. What is that? R and theta. Because x equal to r cos theta, y equal to r sin theta. X is function over r theta, y is function over r theta. X and y are independent to each other. Oh, I'm sorry. X and y are dependent upon r and theta. Being r and theta are independent to each other. This is a typical, a different kind of scenario that it is showing to the people. This is how it is. Okay, no, leave it. Okay, I dump r theta concept at all. Tell me about the x-axis and y-axis. Only x-axis. If I take only x-axis and y-axis, there is one independent component that called x-axis. Y is dependent upon it. If I talk in r theta plane, then only theta is dependent, r is dependent upon it. But if I take a hybrid model where r is going like this, making angle theta, and x and y is like this, where x is function over r theta, y is function over r theta, then r and theta dual independent components are coming. Whereas x and y are dependent on r and theta if it is a hybrid model. This kind of miniature, that's why channel name is Min Ink, miniature science. This kind of miniature science is not available in any of the book. Anyone can try. Okay, now if that is the scenario, then how to proceed upon? Now consider that idea is to calculate the length of the ith section. Summation I equal to 1 to n length of the ith section. Length of the ith section must be found as independent component. Only set of independent component, no dependent component. Okay, if that is the case, then what is length of the ith section? Length of the ith section we have calculated delta x square plus delta y square square root. If someone watching it all the videos. So if this is a circle and I have to find the length of the circumference. In that fashion, I chop the circumference into n parts. If I talk about the ith part, then this is the ith part and this is the circumference. What is the length of the circumference? Consider this theta of the ith part, the theta, delta theta I is very small. Then circumference will behave like a straight line. If it is a straight line, this is a straight line, I want to measure this line length. Then if I consider the horizontal side of this, then this is delta x on x-axis. If I take vertical side of it, this is a delta y. Vertical side and horizontal side, it forms a triangle. And third side is hypotenuse. I'm talking about this triangle. If this is the hypotenuse, then there is a triangle. Knowingly, unknowingly, it is forming like this. This is vertical, that is delta y. This is horizontal, that is delta x. And this is the arc. Okay, this is the ith section. This is the ith section of the chop. Okay, in that fashion, this is the straight line arc. Line is straight because we made delta theta I. This is delta x, this is delta y, and this is line. What is length of this arc? Delta x of the ith section whole square plus delta y of the ith section whole square root. Okay, summation of I equal to 1 to n. If I sum it, now this, see that this part, the summation, if I make the Li, length of the ith section must be in the independent component. Must be in the, no. But delta y is dependent on x. Y is dependent on x. Okay, if y is dependent upon x, okay, right now leave it. If y is dependent, what is delta y? Y equal to a square root of a square minus x square. That is the equation of circle. So y is dependent upon x. I can produce delta y in x also, no problem, because they are related and y dependent. So it can be done. Then how to convert into integral calculus? Because n tends to infinity, so many sections are there. If I take integral calculus, then n tends to infinity. Integral calculus is made like that. That model is made like that, that n tends to infinity. In that fashion, this, the equation what we are writing, delta xi whole square plus delta yi whole square root I equal to 1, I equal to 1 to n. Okay, if I write like this, then it will become a calculus of square root of dx whole square plus dy whole square root. This is what is written in the book. Go and check the book. Summation of I equal to 1 to n. Square root delta xi whole square plus delta yi whole square can be written as integration. X is from one location to another location. Here x is minus a to a. If it is a circle, then x is minus a to a. X is minus a to a. In that section, we will talk about the top part of the circle only. Because x, y, if I take in x and y, then this is x axis, this is y axis, and x is from here to here, it will cover this section only. Then I have to multiply by 2 or add it from minus a to a. If I right now I am doing minus a to a, then again you have to add a to minus a, but 1/2 only will do. X is minus a to a, and a square root of dx whole square plus dy whole square, that will be like that. What is dy? y equal to square root of a square minus x square. Dy will be minus x by square root of a square minus x square. A is the radius of the circle. It can be transformed into integration x equal to minus a to a square root dx whole square minus dx whole square plus minus x by square root of a square minus x square whole square dx whole square again, because dy equal to square root of a square minus x square, dy equal to minus x by square root of a square minus x square dx. Now everything will come as a dx, take out dx, dx whole square, take out dx. It will become a square root of 1 plus x square by a square minus x square dx. This is what is written in the book. First thing is that first idea concept is bring the first concept is bring the kind of a generic length. Generic length. Generic length is delta xi whole square plus delta yi whole square root, where y is dependent upon x. Okay, for time being it is all right. Means there is a piece in heart that y can be brought up into the x term, so it will came as independent component x1. It came as independent component of x1. But how? This is the first part. Bring the generic equation in summation and length of the ith part in independent component. Well, if I talk in y and x, then it must be only in x. If y is there, then there should be relationship between y and x, so that we can bring. It should be only in independent component. Next is transforming it to integral calculus. That is next part. If it is delta xi whole square plus delta yi whole square, I can take out delta xi from here. It will become delta xi square root 1 plus delta y by delta x whole square. Makes sense? It will become a square root of 1 plus delta yi by delta xi whole square into delta xi outside. If delta y is a function of x, then delta y by delta x, that is the dy by dx, loosely, dy by dx, it can be brought in the function of x1, means 1 plus delta y ith section by delta x ith section whole square. A square root is a function of x only, and that side we have delta xi. Now more or less it becomes summation I equal to 1 to n function over x into delta xi. Many times I have demonstrated this. If this is x-axis, and this is y-axis, okay, if I have a curve like function over x, this is x-axis, this is y-axis, or I can say if this is x-axis, then this is function over x-axis, this is x-axis, then this is function over x-axis. If that is the case, then if I draw a graph like this, then at any moment, if it touches the graph, this is the graph. At any moment in x, if I go up, it will touch the graph. That is the function of fx at x equal to x. If I have summation of I equal to 1 to n fx function over x, that is the square root of 1 by 1 plus delta yi by delta xi whole square, that is fx function over, it is not fxy, it is not function over x and y. There again miniature signs comes. This is not function over x and y, this is function over x only. Okay, so if I have function over x, okay, in the ith section, if I chopped x-axis, right now it is theta. Theta is going 0 to 2 pi, and we have chopped the theta arc. So it is theta. Consider it x-axis. Now, if I chop x-axis into, I'm sorry, let's make it theta only, it will be clear. I chop the theta angle from 0 to 2 pi. This is theta angle and this is function over theta. Okay, I'm sorry, consider x only, because we have taken into x. Anyway, we have chopped theta into n part, that is true, but we are computing things in x and y only. Let's go with x and y. Now, if this is x-axis, I chop x-axis into n part. Consider ith part. Ith part, if I say, then summation of I equal to 1 to n function over x of the ith part, means this is the distance. Function over x when x is in the ith part. Okay, that will be, if this x-axis is 0 to a and I chop into n part. Each part is the width of a by n. A by n. Ith section will be a by n into I. That much is the x. Function over x of the ith section, this distance, that is this height. Function over x means this height into delta xi. This will give the area of this section. If I add area of all the section, it will give the full fx dx. It is exactly same here. Summation of I equal to 1 to n. Function over x of the ith section delta xi. Function over x is vertical. Delta xi is the small straight. If I multiply, it will give the area of that section. If I add all the section the way we are doing in summation, it will give full fx dx. Now I can rewrite as integration. X is minimum to maximum. In circle, it is minus a to a. Minimum to maximum fx dx. Okay, we can proceed here. Okay, someone can. There is nothing hidden here. Okay, fx is now delta y by delta x. Delta y of the ith section by delta x of the ith section. It will be turned into dy by dx. Division will turn into differentiation. The way we said multiplication will turn into integration. It will become 1 plus dy by dx whole square, a square root. That is a function over x, dx. X is minus a to a. What is dy by dx whole square? That will be x square by a square minus x square. If we settle down, it will become a by a square root of a square minus x square dx. A you can keep outside, dx by square root of a square minus x square. Sine inverse x by a. X is minus a to a. Sine inverse 1 minus sine inverse minus 1. That will be pi by 2 minus pi by 2. Pi. It will pi. Pi. Okay. Then length will be pi into a for the top part, 2 pi a. Anyway, idea is not to compute the length. Idea is first to bring the ith section. If I trying to calculate the area of the circle, consider I'm trying to calculate area of the circle instead of the length of the circle. I know now this is the radius, and radius is moving like this. Okay, it is making one section like this. This is the first section of the area. If radius moves like this, this is the first section. This is second section. This is third section. This is fourth section. This is ith section. Like that, I chopped into n part. What is your ith area? This is my ith area. What is your first area? This is my first area. This is my ith area. Angle is delta theta I. What is area of this? Whatever it is. What is the net area of the circle? Sum it. Summation of I equal to 1 to 1 area, capital A of the ith section. Similarly, if someone add the area of the ith section, then he gets the full area. What is area of the ith section? In x and y. If someone is trying to calculate in x and y area, area means it should have two independent components. If there was a length, length needs one component. Length means one component. We did for x. Then that's why there was delta xi. If I compute area, there must be two independent components. Any area has two sides. Area has the basic area in Cartesian coordinate system is rectangle, and it has x-axis and y-axis. If I want to compute area in a generic fashion for the ith section, there must be two independent components. One is x side and one is y side. They should not be dependent upon each other. If I go the fundamental I did with the finding the length of this length of the curve the way we did, it was in delta x and delta y, but y is function over x. Similarly, if I try to find area of ith section in x and y, area of ith section in x and y means it will come as delta x and delta y, where y is function over x, because y equal to square root of a square. This will not work. Okay, it will work. I have seen it is working. How you have seen it is working? I have seen the area of the ith section is, this is r, this is r. R 1 by 2 r into r delta theta. R delta theta I is this r. If I consider delta theta is very small, this arc will become a straight line. Now this straight line into this line by 2, 1 by 2 r into r delta theta I, 1 by 2 into r delta theta I, 1 by 2 r square delta theta I, where r can be function over theta. Summation of I equal to 1 to n 1 by 2 r square delta theta I. See, it is workable. Boss, it is workable in r and theta because the way you are showing r and theta, they are in Cartesian coordinate system. R and theta is not in r theta plane. You are still in someone is still in Cartesian coordinate system only. If someone is still in Cartesian coordinate system, that's why r is rotating like a circular manner. Otherwise, if it was a r theta plane, it was a rectangle in the r theta plane. Rectangle in the r theta plane mapped as a circle in xy plane with the relationship as x equal to r cos theta and y equal to r sin theta. Whatever radius we are showing, it is moving like this. It is in Cartesian coordinate system xy, not in r theta plane. Here r and theta are independent component and x, y are dependent component. I can show area in independent component where theta and r are independent to each other and x and y are dependent upon theta and r. So I can place the ith section area of the ith section at two independent components. One is theta and one is r. Workable. Summation of I equal to 1 to n area of the ith section. Area of the ith section is 1 by 2 r square delta theta I, where we are mentioning in r and theta, and both are independent component in the Cartesian coordinate system. If I try to solve it into x and y, it is not possible because x and y is dependent upon x. Both should be independent to each other. I know it. Go to r theta plane and then do in xy. Makes sense? The way we did in xy plane with r theta, considering r theta is dependent in x and y, do in r theta plane. In r theta plane, r and theta are dependent upon x and y. What is that? R equal to x cos theta. R is function over x and y. I'm sorry. X equal to r cos theta. X is function. I'm sorry. R should be function over x and y. R should be okay. R equal to square root of x square plus y square. R is function over x and y. Tan theta equal to y by x. Theta equal to tan inverse y by x. Now you can draw a curve in theta r plane, and this curve will be in x and y. Then do in x. Someone can do. I tried. It is very difficult. Someone can try. But if I am trying in xy coordinate system, Cartesian coordinate system, I cannot compute the ith section area in x and y because x and y are dependent on each other. I can compute in r and theta because both are independent in terms of x and y. Two independent components can form a generic ith section also. So in x and y, the way we did finding the curve length in x and y, knowing that it will come to x only. Similarly, I cannot find the area of the ith section in x and y, knowing that y is function over x. Not possible. Because it will come as, at the end, it will come as delta xi delta yi. Delta xi delta yj. Dx dy integration will come in dx dy, where dx and dy both should be independent of each other. Then only it is possible to compute the ith section area. Okay, last time we were discussing about length vector. Length vector means if I'm trying to calculate area of something, then I do the cross product of two vectors. If this is the vector, this is another vector. If I do cross product of these two vectors, I get the area underneath this vector and this vector. If I do cross product, I know it. Try it. Okay, if this is the circle and this is the radius, this is the ith section. Okay, if this is the ith section, then what is, if I try in xy coordinate, this is origin. Consider this point is x comma y. What is length vector of this? There is another vector like this, that is a curve vector. If I get curve vector in x and y, that is length vector. Please see our previous videos for the length vector. There is a dedicated video series on the length vector. If I know the length vector of this curve and length vector of this, then just do the cross product. That's it. You get the area of the ith section. Simple, right? What is the length vector of the curve? generic vector in xi plane is xi plus yj. Length vector of the curve will be, I take out x from here, then it will become I plus y by xj bracket close into x. Length vector of the curve will be I plus dy by dxj bracket close into dx or delta x. What about length vector of this straight line? Length vector of the straight line, if I'm talking, then I have, since it is area, I have to take out y as independent component. Now it will become y and bracket dx by dy plus j. It will become dx by dy I plus j bracket close dy. Do the cross product. Cross product will be I plus dy by dx j bracket close dx cross product dx by dy I plus j bracket close dy. It will not work. This is what I am saying. It worked. Last video someone is watching. It worked. It worked in polar coordinate system. In polar coordinate system, any point, any vector point is r unit vector plus r theta unit vector. First take theta as independent component, it will become dr by d theta r unit vector plus r d theta by d theta unit vector bracket close d theta cross product. Take r as independent component, dr by dr r unit vector plus r d theta by dr theta unit vector bracket close outside dr. Do the cross product, you will get the area of the ith section. This is what we did. This is possible because r and theta are independent component in xy plane. But if I take in x and y, then x and y are not independent component together. What is the solution? Okay, so two length vector. One length vector is straight line and one length vector is a curved line. This is what we did in the last video. This is the radius vector, more or less radius vector where theta is constant. This is the arc vector where theta and r may not be independent to each other, whatever it is. So for this vector, I take theta as independent component and brought the vector equation. For this vector, I took r as independent component and brought the vector. Did the cross product, I got the ith section area, did the summation, brought it into integration calculus and solved it. If I bring this as a dx, delta x variation, as in x and y, and bring this in delta y variation and do the cross product, it will not work. The way it worked in r and theta, please watch previous video. Why it will not work? Because that we will talk. Why it will not work? Let's go a little bit beyond what it is now. If I take x as independent component and y as independent component and do the cross product, first vector is 1 plus dy by dxj bracket close dx cross product. Second vector is dx by dy I plus y because I have taken y out plus j bracket close dy. Okay, now keep dx and dy outside. First is dx, first is I plus dy by dxj cross product. Another is dx by dy I plus j. What is the first one? First one looks like dp by dx, where p is the position vector of xi plus yj. What is dp by dx? That is I plus dy by dxj, exactly same. Another is dp by dy. Another is dp by dy. That will be dx by dy I plus j. One is I plus dy by dxj. One is dx by dy I plus j. That will come as dp by dx cross dp by dy. Makes sense? What is p? P is a point in xy plane. How much P is a point in xy plane? Okay, xy plane. Now I am saying this point is x comma y. How much x comma y would move if I move 1 unit in x? More or less I am saying how much x would move if I move x 1 unit length. Both are same thing. How much x would move if I move x 1 unit? Anyone would laugh. How much z would move if I move x 1 unit? That is understandable. How much x move if I move r and theta 1 unit? How much x will move if I move 1 unit in x? dp by dy. How much y will move if I move 1 unit in y? So this is something that both are same. dp by dx both are same. What is differentiation? That doesn't make any sense. Okay, so dp by dx cross dp by dy, where y is function over x. Y is function over x. Means if I say dp by dx, point is x comma y can be brought in term of x only. It will be dx by dx. Similarly, if I say dp by dy, both can be brought in term of x only. Dx by dx. What is movement of x when there is one unit movement of x? Sector, not possible. So we cannot bring the area of a circle with cross product of length vector, or generally we find dp by d. If I say, okay, what about dp by d theta? It will work. dp by d theta cross dp by dr. If I do like this, okay, and then d theta dr is theta, then it will work. Someone can try. What is p? P is xi plus yj. X is r cos theta, y is r sin theta. dp by d theta, I'm sorry, dp by dr, keep theta constant. Cross product dp by d theta, keep r constant, and do the cross product. Get the magnitude and then d theta dr. Try to, it will give the area. But dp by dx, where p is xi plus yj, dp by dy, where p is xi plus yj, dx dy will not give the area, because both are why there is only one independent component here. With one independent component, you cannot take cross product of two vectors, not possible, because they will do the same expression. Then we have to find something where x and y, we have to do something so that x and y will be independent of each other. What will be that? Okay, consider this is an assignment. Another assignment is, if a rectangle maps to a circle in xy plane and we have a hybrid model of xy and r theta in xy plane, what about this circle would map? What about this circle would map here? If this in r theta plane I have a rectangle, but if I draw in r theta plane r theta and xy all together, it will form a cosine and sine wave. This is what we saw. Can we calculate this dp by dx cross dp by dy in r theta plane? Then it is possible. This assignment, or in xy plane itself, how I can proceed that I will have x and y as independent component, not dependent upon. Then it is possible. These are $1 trillion explanation on the dependency, because if someone understands dependency and independency, then only someone can understand artificial intelligence and machine learning, where features are components, and someone must understand that how they are collinear to each other. That is the basic of that. Anyway, please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.